All right, hi, Introstat student. So today, I just want to talk about the new unit, Unit 9 on random variable. Look at this, random variable. So the very first lesson is on discrete random variable. Now, the thing with this unit is some of you might be happy with this, but I am not because th- for this unit, there are no quizzes, right? And on top of that, there are 73 topics. So, and the unit test is 21 questions. So, it's a lot. So, I've decided that, to help you do the exercises instead. Okay. So if you go to your account, look for random variables unit and under discrete random variable, the first three are videos. So I'm not going to touch that. I want to go to constructing probability distribution. So it's pretty easy. So let's go through this. Um, okay. I hope. Okay. Constructing probability distribution. Okay, so let's dive in. So first question says Caroline has a unique pet chimpanzee that is relatively likely to have twins. So each pregnancy is independent, and Caroline's chimpanzee has a 60% chance of having one baby and a 40% chance of having two babies each pregnancy. Okay, so if X is a random variable that represents the total number of chimpanzee babies if Caroline's chimpanzee gets pregnant twice. So if the first time she gets pregnant and then she gives one baby, okay, that's a 60% chance of that happening. Then the second time she gets pregnant, and then she can give another baby, right? So she can have two babies if she gets pregnant twice. But she can also get four babies. So the minimum amount of babies, number of babies that she can get from two pregnancies, two, and the maximum number of babies that she can get from two pregnancies will be four. So if you look at the graph, so there's a minimum two, then followed by three, and then followed by four. And you're supposed to count the probability, right? You're supposed to graph the probability distribution for all possible values of X. And X is the total number of chimpanzee babies if the chimpanzee gets pregnant twice. So let's go back to the idea here, right? Now, I want to talk about.
If you have a green
Uh-oh.
RAV4 in the west parking lot, please go and move that car, please, for the drive.
Okay, sorry for the interruption. All right, um, so for Caroline to have two babies from two pregnancy, that means the first baby, first pregnancy, first pregnancy, followed by second pregnancy. The first pregnancy is one baby. Second pregnancy is also one baby. In total, two babies, right? One plus one gives you two babies. So minimum is two babies. What's the probability though of Caroline giving birth to one baby? It's 60%, so zero point 0.6. Now, they say that each pregnancy is independent, which means you can actually multiply the probability. Zero point 0.6 times zero point 0.6 is 0.36. Okay? So, how about when she has four babies, right? So, first pregnancy, second pregnancy, four babies, which means the first pregnancy she will have to have two babies. The second pregnancy, also two babies. And it says here there is a 40% chance for Caroline's.
Attention students, I need to please come to the front office. That's Pa. Please come to the front office.
Okay, I hope Pa got the message. So 40% chance of having two babies. So here be 40% chance times 40% chance. So two babies plus two babies equals to four babies. And 0.4 times 0.4 is 0.16. All right. So then you can graph this, right? You can graph this. So for two babies is 0.36, 0.4 babies is 0.16. I need to write this down somewhere. If not, I will forget. So two babies is 0.36, and then four babies is 0.16. All right, let's go. So that's for two babies, you drag to 0.36, which is about here, halfway between 0.32 and 0.4. And four babies, you drag to 0.16 right here. So how about three babies, right? Three babies. Now you can actually calculate. So first pregnancy and second pregnancy. So first pregnancy could be one baby, and then second pregnancy could be two, and that will give you three. But there's also a chance that the first pregnancy could be two babies, plus then the second pregnancy could be one baby. It will still give you three. So there are two different scenarios. So probability that the first pregnancy has one baby, right, is 0.6, right? Times what's the probability of the second pregnancy having twins? 0.4. So that is 0.24. Same idea here, right? If the first pregnancy is two babies, there's a 40% chance, which is 0.4. Multiply the second pregnancy of one baby, which is a 60% chance, which is 0.6. You take 0.4 times 0.6 is 0.24. And then you add those two up. You add this and this, right? Because it's a union of this scenario and this scenario. So it's or, right? It's this scenario or this scenario happening. So if it's or, it's adding, right? In statistics, we always add. So 0.24 plus 0.24 is 0.48. Now I want to show you something. Here you have 0.36. Here you have 0.16. So if you add those two, 0.36 plus 0.16, if you add those, you will have 2 here, 0.52. Guess what? What is 0.52 plus 0.48? You got it. It goes to 1. So for probability distribution, it will always, always, always add up to 1. So we could have just not calculate we could have just leave this alone and not calculate it, and just simply add 0.36 plus 0.16, which we got here, and then subtract away from 1. So 1 minus 0.52 is 0.58, which is exactly what we got if we have just done the math. Okay, so 0.48, right? So let's go up to 0.48, and this is it. Okay, so let's do another one. So here, constructing probability distribution. Camilla just got a brand new pet lizard, and she collects data 3 times a day for 10 days to see if a lizard is awake or asleep. She has too much time on her hands. The table below shows her data, right? A represents awake, right? An awake lizard, and S represents a sleeping lizard. So drag the bars to make a relative frequency plot that shows the proportion for each possible number of times the lizard is sleeping in a day. This is almost like a simulation, right? She runs a simulation. She collects data for 10 days, 3 times a day, right? 3 times a day for 10 days, which is why you have to see 3 times a day, 1 time, 2 times, 3 times, right? 3 times a day, and for 10 days. So from that data, right? From that data, you try to figure out, okay, how many of those 10 days was the lizard asleep in a day? So here, 3 times the lizard was asleep, right? So if you look at the graph, you see that 0 times that lizard can be sleeping. One day, 1 out of the 3 that it could be sleeping. 2 out of the 3 times it could be sleeping, or all 3 times during that day, during a day that the lizard would be sleeping. So let's do kind of so lizard sleeping. So let's say 0 days, 0 times lizard sleep. So here, where is 0 time? Awake, right? So this is 0 times. So there's 1 time, 2 time, because out of the 3, see, awake, 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 awake. It's not sleeping. And here, awake, awake, awake. So 3 times. Anything else? No. Okay, so 3 times. 3 out of 10. 3 out of 10 times the lizard was asleep. Was awake. So he wasn't awake, right? He wasn't sleeping. Sorry, he wasn't sleeping. So how about 1 time? 1 time, right? 0 times. 1 time that the lizard was asleep. So here is asleep 1 time. Here is 2 times asleep. Here is 1 time asleep. And this 2 times asleep. This is 1 time asleep. Here 1 time asleep. So 4. So 4 out of 10. How about 2 time? 2 time. So 2 time. So we already used this. We already used this. 2 time asleep. We already used this here 2 times. So 1. We reuse this. We reuse this 2 time asleep. 1, 2. And that's it. So 2. So 2 out of 10. Now, how about 3 time? 3 time that the lizard was asleep. 1, 2, 3. So that's only 1 day. 1 out of 10. 10. Okay? All right? So 3 out of 10, 4 out of 10, 2 out of 10, and 1 out of 10. All right. So 3 out of 10. 3/10 that the lizard was sleeping. Okay? Actually, did we get it right? No, I think we might have. Oh, we need to reverse it. So it's 1 out of 10, and then this is 3 out of 10. So for 3 out of 10, which is 3/10, this is 1 out of 10, and this is 4 out of 10, and this is 2 out of 10. Right? Oh, did I get it wrong? Crap. A is awake. So lizard sleeping. Sleeping, it's only 1. Three times is sleeping. Ah, I got it right the first time. Dang it. Okay, so this is 3/10. So for 1 day, it's 4/10. And then this is 2/10, right? So I was right the first time. Okay, so hopefully, maybe we can do another one. So a factory is making a total of 10 different 4-piece desks. At the end of the manufacturing process, the workers inspect each piece to see if it's in mint condition or it's damaged. The data from the inspection process is shown in the table below. M represents a piece in mint condition, which is really good condition, and D represents a damaged piece. So drag the bars to make a relative frequency plot that shows the proportion for each possible number of desk pieces in mint condition in the 4-piece desk. So 4-piece desk could be 0-piece, right? Mint condition could be only 1 out of the 4, could be 2 out of 4, 3 out of 4, 4 out of 4. All right. So we need to 0 mint condition. All right, 0 mint condition. This is 1 mint condition out of the 4. Okay, this is 2 mint condition out of the 4. This is 3 mint condition out of the 4. And this is 4 mint condition out of the 4. So 0 out of the 10, how many would that be? 0. So mint, 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 not mint, 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 mint. So it looks like none. There's 0, right? 0 out of 10. So 1 mint condition. 1 mint is right here. There's 1 mint condition, 2 mint condition out of the 4. So 2 out of 10. So 2 mint condition, 2 mint, 2 mint, 2 mint. So there's 2 here. So there's 1. There's 2 mint. There's also 1. So 2. So 2 out of 10. How about 3 mint condition? 3 mint. 1, 2, 3. So there's 1. That is. Okay, this is used. It's 3 mint. So there's only 1 out of 10. So how about 4 mint? So this is 4 mint. 1, 2, 3, 4, 5. 5 out of 10. And if you add up, so 2 plus 2 is 4. 4 plus 1 is 5. 5 plus 5 is 10. So 10 out of 10 is 1. It will always add up to 1, right? The total will always add up to 1, the probability. So 0 out of 10, 2 out of 10, 2 out of 10, 1 out of 10, 5 out of 10. So I need to then go to this. So for 0 is 0. And then for 1 is 2 out of 10, which is 0.2. For 2 is 2 out of 10, which is also 0.2. For 3 it's 1 out of 10, 0.1. And for 4 is 0.5. Okay, I hope you understand what we're doing here. If you have any questions, let me know. Thank you.